Hello students, in previous session we've learned that everything we see around us is made up of matter. That is, matter makes everything. We've also learned that matter is made up of particles. That is, matter is not continuous but is particulate in nature. We also learned about interparticle spaces, and interparticle spaces are present in all types of matter. Their size and number can vary from one form to other. First topic of today's discussion is characteristics or properties of particles of matter. I repeat, it is characteristics or properties of particles of matter. Here we will understand some important properties of matter. Let's begin with the first property. It states that particle size is extremely small. We've learned that matter is made up of particles. The particles differ from one matter to other. That is the type of particles. The size of particles differ from one matter to the other. Now the question is, what is the size of the particles? About the particle size, generally they are very small. But their size again varies from one form of matter to the other. Actually, the particles which constitute a certain type of matter are so small in size that we cannot even see them directly with our eye. They are so small in size that they are not visible to us. What we actually see is a combination or collection of number of such small tiny particles. In order to demonstrate the particle size and the number of particles present in matter, let us consider a simple activity. Put a few crystals of potassium permanganate, purple in color, in water. And the water is taken in a glass cylinder. The color of the solution will be very dark. In the next step, transfer a part of this solution into one more cylinder and fill it with water again. The intensity of the purple color will now get reduced. Repeat the same experiment 3 to 4 times. At the end, we get to a stage wherein the purple color of the solution will not altogether disappear, but we can observe that some color will always remain even when the solution is very dilute. Hence, from the above experiment, it can be stated that one crystal of potassium permanganate, which seems to be very small in size, is actually made up of large number of tiny particles. I repeat, one crystal of potassium permanganate, which seems to be very small in size, is actually made up of large number of tiny particles. Hence, matter is made up of particles and the size of particles is extremely small. This was the first property of particles of matter we have studied. Now, let's go to the next property. Next property says that particles of matter have space between them. Okay, let's start with this property. If we recall the two activities we have considered till now, one adding salt to water and one more adding potassium permanganate to water. Here, water, salt and potassium permanganate all are made up of particles. That is, matter is made up of particles. When we add salt or potassium permanganate to water, the particles of salt or the particles of potassium permanganate would occupy the spaces between the particles of water, and hence we obtain a solution. I repeat, when we add salt or potassium permanganate to water, the particles of salt or the particles of potassium permanganate would occupy the spaces between the particles of water, and hence solution is obtained. Hence now it can be stated that particles of salt or potassium permanganate would occupy the interparticle spaces of water. Hence particles of matter have space between them. Till now we've discussed two properties of particles of matter. One, particle size of matter is very small or extremely small. Second property, particles of matter have space between them. Next property of matter which we will learn is particles of matter are continuously moving, or they're always in motion. So far we've learned from our discussion that matter is made up of very small particles and they are separated from one another by empty spaces, and these empty spaces are termed as interparticle spaces. Now we get a question here: are these particles stationary, that is, are they at rest, or are these particles are in a state of motion, that is, are they moving? The answer would be the particles are not stationary, that is, they are not at rest, they are in a state of motion. We would have read in newspapers that a poisonous gas like ammonia or chlorine has leaked from some factory and has also polluted the nearby area. This clearly shows that the particles which were released from a certain place have spread over large distance or large area. Because of the rapid movement from one place to the other, and this type of particle motion is termed as diffusion, and this diffusion is maximum in case of gaseous state of matter, whereas this diffusion will be minimum in case of solid state of matter. Now let us consider a simple example to understand that particles of matter are continuously moving. If we go to a temple, we find incense sticks. We also call them as agarbatti sticks. To feel their smell, you have to go near them. Whereas, now if you light one of these with a matchstick, the fragrance will immediately spread and can be felt even from a distance. I repeat, if you were to light that with a matchstick, the fragrance will be immediately felt from a distance also. Now what does this indicate? It indicates that the particles or vapors released by the incense stick on burning have spread and got mixed with air. Hence, now it can be stated that particles of matter are continuously moving, that is, they are in a state of motion. Now, let us recall the three properties of particles of matter we have studied till now. First states that particles of matter are extremely small in size. Second, it states that the particles of matter have space between them. That is, we describe about interparticle spaces. Now, third, we've just learned that particles of matter are in motion. The next property we're learning is particles of matter attract each other. The particles of a substance have certain force of attraction between them. This keeps the particles together. The magnitude of the force of attraction depends upon the nature of the particles which constitute matter. It would also depend upon the interparticle spaces. I repeat, the particles of substance have certain force of attraction between them, and this would keep the particles of the matter together. Now, let us consider an example. The attraction is maximum in case of solid state of matter. This is because the particles are very closely packed. This force of attraction is less in case of liquid state of matter, and it would be least in case of gaseous state. I repeat, the attraction of the particles of matter is maximum in case of solid state of matter because the particles are very closely packed. The same force of attraction is less in case of liquid state, whereas least in case of gaseous state. In case of gaseous state, the force of attraction between the particles of matter is least. This is because in case of gaseous state of matter, the particles are far separated and the interparticle spaces is maximum. Hence, for this reason, the attraction between the particles in gaseous state will be least. Now, let us consider a simple example to understand that particles of matter attract each other. Take a piece of chalk, a small piece of brick, and an iron nail. Beat them separately with hammer. What do we observe? It is very easy to break chalk into small pieces, difficult to break brick, and very extremely difficult to convert iron nails into pieces. This indicates that the attractive forces are least in the particles of chalk, the attractive forces are more in case of brick, and the attractive forces are maximum in case of iron particles. Hence, it can be stated that particles of matter attract each other, and therefore interparticle attraction keeps this particle close.